Okay, guys, welcome. Today we're going to talk about multiplication and division of rational expressions. Okay, so if you haven't already, I would view the video on simplifying rational expressions because it's going to be very similar to that. Now, when we multiply and divide rational expressions, it's very similar to how you handle regular fractions, right? So, for example, if you want to multiply, I'll just do sort of this symbolic example here. If you want to multiply a over b times c over d, you multiply across. So you get ac over b times d, right? Just like if you have 3 over 4 times 1 over 2, you multiply across and you say this is 3 over 8, right? So this is very similar for the rational expression case, all right? Now part A is just a fraction example, but you can do it real quick. Right? If we multiply across, we get a 15 over 8, and we can't cancel anything, so that's a 15 over 8, and there's nothing else we can do with that. Okay, in part B, we have a 3 over 4 times an x minus 1 over 2. Right? So now if we multiply across here, and actually, let's pretend that this wasn't here. Okay, now, as soon as you see a plus sign or a minus sign, and if that's the only thing on that fraction, you want to go ahead and put it in parentheses, right? So I kind of steer us in the right direction, but I want to make sure that if you have pluses or minus, make sure that if it's not already in parentheses, that it is in parentheses. Of course, if it's a single term. So now when we multiply across, we get a 3 times parenthesis x plus 1 over 8. And that's the best we can do with that. Okay, part C, we have an x minus 1 over 2 times an x plus 1 over x. All right, so again, I see that I have minuses and pluses, so I want to go ahead and put those terms in parentheses. So this is going to become an x minus 1 times x plus 1 over 2x. Okay, part D, we have a 3 over 4x times an x minus 3 over 2y times an x plus 3 over y minus 1. All right, so again, anytime you see sort of the multiple terms there, we'll put them in parentheses. And in the top, essentially just smashing these together, we're going to get a 3y, x minus 3, x plus 3. And in the bottom, we're going to get, let's see, I could combine my numbers here. My 4 and 2 would give me an 8. And then x times y, we'll just say is xy. And then y minus 1 we'll tack on to the end. Right? So usually when you're doing this, you can get away with multiplying your numbers together and then writing the product of your single terms out front, and then anything in parentheses would come afterwards. Okay. Now, remember that when you divide fractions, what do? Well, we keep change flip, right? So if we want to divide fractions, we can think of this as a over b times d over c. So we get an AD over BC. All right, so just like if you wanted to do 3 over 4 divided by 1/2, we know that this is the same as 3 over 4 times 2 over 1. So you get a 6 over 4, which is 3 over 2. Right? So again, this is very similar to the way that we do it for rational expressions. Okay, so part A, we just have a fractional example. So if I want to divide 2 over 5 by 3 over 4, I do my keep change flip. And now this will become an 8 over 15. Okay, part B, we have a 2x over x minus 1 divided by x minus 2 over x. And that's a very bad divided by sign. Okay, that's better. So of course to divide, We know the first thing we have to do is keep change flip. I have my multiple terms there, so let's go ahead and we'll put those in parentheses. So now when I multiply across, I'm going to get a 2x squared times an x minus 1, x minus 2. Okay, part C, we have a 3a to the third b squared over 2cd divided by c minus 1 over a 2a squared b. Okay, so again, first things first, we'll keep change flip. So change this to multiplication, and if we flip this, this is now 2a squared b over c minus 1. I'll put that in parentheses. So now I'm going to get 3 times 2 in the top will give me a 6. I'll get a power of a to the fourth and b to the third. And then in the bottom, we'll have a 2cd times c minus 1. Okay, part D, we have a 2x over y divided by a 3y to the third over x minus 3. So again, we'll keep change flip. And we'll put this in parentheses. So it looks like we're going to end up with a 2x times x minus 3 in the top and a 3y to the fourth in the bottom. And it looks like that's the best we can do there. Okay, finally, part E, we have an x over 2x plus 1 divided by an x plus 2. X minus 2, sorry. Now, in this case, when you go to keep change flip, it's going to be helpful to think of x minus 2 as being over 1. Right? And of course, we'll need to put parentheses here. So when we keep change flip, we're going to have an x over 2x plus 1 times a 1 over x minus 2. So now this in parentheses as well. I missed that the first time. So we're going to get an x over 2x plus 1 times an x minus 2. Right, and in all of these examples, you want to leave everything just in its factored form. You don't want to distribute that denominator out or anything. Okay, now one thing that's not in here that I do want to mention before we do these next bit of examples is that when you multiply or divide rational expressions, first, before you do anything, is you want to simplify each expression. All right, so you want to factor. So what do we mean by that? We mean you want to factor everything and cancel as much as possible. Right? Then you multiply or divide. And then you're going to simplify again. All right, so let's do a couple of examples of that. So in part A, we have 3x to the third minus 27 over 12 minus 6x, and we're multiplying that by a 2x squared minus 4x over x plus 3. Okay, now first I want to factor everything, right? We want to simplify and cancel as much as possible. So this 3x to the third minus 27, that's a difference of 2 cubes, right? So I'm going to, well, I can even factor a 3 out first. So I'll have a 3x to the third minus 9, right? And I guess, let's see, should we even, we'll see. We could factor that, although 9 is not a perfect cube, so we actually can probably just leave that alone. All right, it looks like in this part, we can factor a 6 out, and we'll have a 2 minus x. Okay, next we have, let me use a different color. Over here, we have a 2x that can come out, and then we'll be left with an x minus 2. All right, and then finally, down here, we can't do anything, and that's just x plus 3. Okay, so it looks like what we have now is we can multiply across, and we'll get we can actually simplify this and make this a 2. So now when we multiply across, we're going to get a 2x times x minus 2, x to the third minus 9, over a 2 and then x plus 3 and 2 minus x. Okay, so now we can't cancel much, although we can look at these two, and we can also cancel out our 2's here. All right, now if we employ our trick with a negative, I can multiply the top and the bottom by -1, and I'll use it in the bottom, so we have a -1 times x minus 2 times x to the third minus 9 over a -1 times an x plus 3. Sorry, I said I was going to use it in the bottom. So we have an x plus 3, and now this is x minus 2. So now we can cancel these two. We have a -x times x to the third minus 9 over x plus 3. All right, we were close to being able to factor that top, but it's not quite a difference of cubes. Okay, anyway, part B, we have a 2x to the third plus 3x squared over 10 minus 20x divided by a 2x squared plus 3x over 10x minus 5. Okay, so now when we factor, in the first pair, I can factor out an x squared. I'll have a 2x plus 3. And in the bottom, I can factor a 10 out, and I'll have a 1 minus 2x. Now, keeping in mind that we're going to keep change flip for division, I'm just going to change this to multiplication now, and now flip them. So now on the top, I can factor a 5, because now the 10x minus 5 is up top, and I'll have a 2x minus 1. Right, and then this will be over factor an x out, and then we'll have a 2x plus 3. Okay, so now when we multiply, we're going to get a 5x squared times a 2x plus 3 times a 2x minus 1. And in the bottom, we're going to get a 10x times a 1 minus 2x times a 2x plus 3. So we're going to get a lot of cancellation here. We're going to be able to cancel out 5 and 10 and leave a 2 there. We're going to be able to cancel out this x with one of these. The 2x minus 3's go away. And if I multiply the bottom by a negative and the top by a negative, but I'll use it in the bottom, I'm going to be left with an x times a 2x minus 1 over a 2 times 2x minus 1. So now these cancel, and we're just left with x over 2. Okay, part C, we have a -2 over 3x squared plus 4x plus 1. And then times a 6x squared minus 4x minus 2 over, I believe, an x squared minus 1. Okay, so a little bit more work in terms of the factoring here. Okay, so, whoops. So here, let's factor this one off to the side. All right, so I need my AC, so 3 times 1 is a 3. And two numbers that multiply to 3 and add to 4, 3 and 1. So we're going to think of that as a 3x squared plus 3x plus 1x plus 1. So we'll factor by grouping. And the first pair I can take out a 3x, and I'll be left with an x plus 1. And I can take a 1 out and still have my x plus 1. So it looks like, of course, -2 we can't do anything with. This is going to become an x plus 1 times a 3x plus 1. Okay. Now in the next term, let's factor this over here. So if I do 6 times -2, well, we can even take a 2 out. So you can say this is 2 times a 3x squared. Let's do that first. 2x minus 1. So now I can factor this part by doing the AC method, and we'll have a -3 if I do 3 times -1. And two numbers that multiply to -3 and add to -2, of course, be -3 and +1. Right? So we can think of that as still 2 times 3x squared minus 3x plus 1x minus 1. And now we'll do our factoring by grouping on this section. With a plus in between. And this is all multiplied by 2. Okay, so now in the first part, it looks like I can take out a 3x, and I'll have an x minus 1. And then I'll have a plus 1 times x minus 1. So it looks like this whole thing will become a 2 all times a 3x plus 1. I actually don't even need that bracket there. Times an x minus 1. Okay. And then over, we see that over here we have a difference of 2 squares, so that's just x plus 1, x minus 1. All right, so I can actually get away with canceling these right away. And I have a -4 times a 3x plus 1 over an x plus 1 squared times a 3x plus 1. So it looks like my 3x plus 1's cancel, and we're left with -4 over x plus 1 squared. Okay, so one last example for this video. So let's see, kind of give myself a little bit more room. Okay, part D, we want to do a 10x minus 2x squared over a -x squared plus 5x minus 6. Okay, and then we have a divided by an x squared minus 25 over a -x squared plus 2x. Right, so it is, okay, yeah. Okay, so let's go ahead and we'll get to work with our factoring. So it looks like in the top of the first one, we can take out a 2x, and we'll be left with a 5x minus, no, just a 5 minus x, right? Okay, now on the bottom, if I factor out a -1, if I factor a -1 out here, I'll get an x squared minus 5x plus 6. So now we can factor this one easily. So this will become a -1. And then what are two numbers that multiply to a +6 but add the -5? That's -3, -2. Now since we're dividing, let's go ahead and we'll keep change flip. And in the next part, I can factor out a, let's see, what an x do. Let's factor an x out, and then we'll have a minus x plus 2. Okay, And then in the bottom, we'll have difference of two squares. So this will be x plus 5, x minus 5. Okay, so now if we multiply across, we have a 2x squared, 5 minus x, negative x plus 2, over a negative 1 times an x minus 3, x minus 2, x plus 5, x minus 5. Okay, so we're close on a lot of this, right? So it looks like we are off by negative on this 5 minus x and this x minus 5. But I do have a negative here, so I'm going to use that negative in here to cancel this out. All right, but now our x minus 2 terms, we have a negative x plus 2 here and an x minus 2 here. So I'm going to use another negative to deal with that. All right, so now if I use this negative in the top, I can then cancel that out. So now these cancel out. And I'll finally be left with a 2x squared over an x minus 3 times an x plus 5. And we'll toss the negative out front. So we get a negative 2x squared over x minus 3, x plus 5. Okay, so that concludes this video on multiplying and dividing rational expressions. I hope you enjoyed, and I will see you next time.